Hello student, today let us discuss about the Lagrange equation is applications to the simple pendulum. So, we can be asked questions like this, obtain the equation of motion of a simple pendulum by using Lagrangian method, and hence deduce the formula for its time period and of a small amplitude and oscillations. So, see here, this is the circuit. There is the pendulum is this one, it's have mass m and it fixed at point C. So, make a oscillations when it shifts to the point A. So, it oscillates and cover the distance S. There is the distance they covering the S, this is the point. Usually it's have a length, the effective length is L. Effective length means it's a distance from the center of the pendulum to the hanging point, that is to be including length, hook and the radius of the bob. So, that is called effective length. So, we will find OA is the displacement. So, it's let it be S. So, S can be given by the relation S is equal to L into theta. Theta is their displacement of the simple pendulum from the point C. So, S is equal to L theta. So, we can be give S is equal to L theta. So, if we differentiate this one, it gives ds by dt and L into d theta by dt, but ds by dt is nothing but velocity and L is the length, effective length. D theta by dt can be written as theta dot. So, this is theta dot, d theta can be written as. So, V is equal to L theta dot. So, we know that the kinetic energy formula T is equal to half mv square, put the value of V. So, that is half m L square theta dot square, let it be equation 3. So, when the bob is displaces from point O to A, so it covered distance S usually. So, then the potential energy it is gained is given by the relation V is equal to mgh. Usually we write that equations of a potential energy is mgh. So, h is the height, so that is m into g. H is nothing but OB in the pendulum. So, see here, this is the height. So, when the bob is turns to A, so you take the perpendicular distance, this is the OB is the height. Such height is covered when it compared to its mean position. So, then OB can be written as CO minus CB. So, if you want OB, then you subtract CO minus CB, then you got the value of OB. So, like this we put here, CO is nothing but length, CB can be length of the CB can be find out using the cos theta definition. Cos theta is equal to adjacent divided by hypotenuse. On this way we got CB is L cos theta. There is L is common here, so we take L is common, mgl 1 minus cos theta, let it be equation 4. and we know that the Lagrangian is the difference between the kinetic energy and potential energy, that is L is equal to T minus V. So, then putting the value of T and V from equation 3 and 4, that we got L is equal to half L square theta dot square, and V value from equation 4 mgl minus 1 minus cos theta. This is the, we get the value mgl 1 minus cos theta. This is the Lagrangian we got. This is the difference between kinetic energy and potential energy. So, now this Lagrangian is differentiate with separately with theta and theta dot. First differentiate this L with respect to theta. So, theta I concern only this one, means L is differentiate with theta, this term tends to 0. It remains only minus mgl 1 minus cos theta. So, if you differentiate this one with respect to theta, we got mgl constant, minus is ok, 1 is 0, minus cos theta is minus sin theta, that is plus sin theta, that is minus mgl sin theta. If we differentiate this one with respect to theta d theta, this term is tends to 0, there is no, because it is a constant, there is no theta dot here. So, this term is tends to 0, only first term, that is this term only remains, because there is no theta dot here. So, it tends to 0. Then dl by d theta is ml square, theta is differentiate with respect to theta dot, 2 cancel. So, that is ml square theta. So, this is the value we got it. So, let this equation say usually 6 and 7, this 6 and 7 equation in the Lagrangian equations of motions. We know that Lagrangian equation of motion is derivative of with respect to dt of del L by del theta dot minus del theta. Put this value del by d theta and del by theta dot, that is d of dt of del by del theta value is m L square theta dot, and dl by d theta is minus mgl sin theta. So, minus into minus is plus and mgl sin theta. So, on simplification, again this term derivative with respect to t. So, ml square is d theta by dt, and usually this same as that mgl sin theta, but d theta dot dt is nothing but theta double dot. The value is theta double dot, this is the ml square theta double dot, because d theta dot by dt is the double theta dot and mgl sin theta. So, on again simplification, we take the similar from the common for mg, ml is the common there, ml square. If we take ml square is common, then theta is remains, theta double dash is remains, and L is short, that is why g by L sin theta remains, and ml square is go to this side into 0 in the next line. So, it becomes 0. So, remaining part of that one is theta double dot plus g plus L sin theta equal to 0 is the equation represent the Lagrangian equation for simple pendulum. Means the Lagrangian equation is applied to the equation of motion. That is why the for simple pendulum the equation derived is the theta dot double dot plus g by L sin theta is equal to 0. If the in case for the theta is very small, then the sin theta tends to only theta, that is why the equation is turns to theta double dot G by L theta is equal to 0 only when the theta is very small. So, theta is sin theta is equal to theta. So, then this is the required equation. Equation 9 is the equation which gives you simple harmonic simple pendulum equation when theta is very small. So, then if you want to calculate the period of the simple pendulum, usually that we have formula, that is T is equal to 2 pi into root of L by G. L is the effective length. So, this is the 2 pi into root of L by G. Okay. Thank you all.